Assalamualaikum and very good day everyone. I'm Hanisah binti Juki from 4BNT. Today I will present my final year project, the study of slow bend test and hardness test for welded rail joint in between Alumino Thermic and flash bar in Electrified double thread project EDTP Gemas-JB. Here are my supervisor that helped me to finish this thesis. First of all, I will start my presentation with abstract of this project. First of all, I will start my presentation with abstract of this project. Abstract: the development of railway project in Malaysia is accelerating from time to time, with various railway projects being developed by Malaysia. The Gemas-JB EDTP project used the welding method to connect the rail, which is a total 197 kilometers with an allocation of 7.5 billion ringgit Malaysia from the government. Most of the railway projects underway in Malaysia now use two types of welding, which is ATW and FBW, which both have the same purpose but vastly different mechanism. The purpose of writing this study is to identify why most railway projects in Malaysia now need to use two types of reconnection welding. The researcher managed to compare these two welds and identify FBW to be much better than ATW in terms of quality and time consuming. However, both methods are important for the completion of any railway project in Malaysia, especially the Gemas-JB EDTP. Okay, next. Introduction. Nowadays, as for the transportation mode, there has been moving towards electrification as one of the main energy consumer, as electrical energy deliver a lot of environmental benefit due to the significant absorption of renewable energies in electric power systems such as KTM commuter. In 2016, the CREC and CCC won the contract to build Malaysia's first electrified rail link between KL and Singapore. Electrical energy delivers a lot of environmental benefit due to the significant absorption of renewable energies in electric power system. The Gemas-Johor Bahru line is the last piece of the current KTMB network to be modernized, and once finished, it will give a continuous connection from the Peninsula Southern Tip to Padang Besar on the Thai border in the north. The fundamental purpose of a rail in a track system are to provide a continuous, hard and smooth surface for train travel, to guide vehicle wheels along a specified track, and to sustain and transmit the load imposed by the wheel to a greater area of formation through slipper and ballast. Okay, next. Thermic welding. Thermic welding is used on railroad to join rails together. The casting process and the actual rail welding are both part of the thermic welding process. ATW was a huge success from the start, known for its low cost. This technology is currently widely used for railway construction, maintenance, and modernization all over the world. They have formulas to describe the extremely exothermic reaction between iron oxide and aluminum particle in alumino thermic welding. Okay, this figure shows the process of ATW formatting of the thermite mixture, and then next pouring the molten thermite mixture into the mold, and lastly crystallization of the weld. Okay, next. Flash bar welding is one of the most commonly used techniques to join rail together, meaning flash and arc are generated by the resistant heating and local heating caused by the contact of the rail. This contact electrification and flash generation is repeated a number of times until a matte layer is formed over the entire joint surface, and a weld joint is then obtained by rapidly advanced and pressurization. Okay, this figure shows the process of FBW, which start from pre-flash process, flash process, and lastly, upset process, the accelerated forward movement and pressurization. Okay, now we move on to problem statement. Rail joint is the most important part in railway. Without a better knowledge about rail joint, the excellence of track may not be produced. There is various methods of the thermic power welding process welding joint. Shapes welding that have been implemented in construction of railway nowadays include in EDTP Gemas-JB. There are two methods of welding that has been used in permanent track, which are Alumino thermic welding, ATW, and flash bar welding, FBW. This paper is to identify why in this EDTP Gemas-JB project are needed two types of method welding rail joint to complete this project. Both methods will be compared to solve the problem. Now we continue with objective for the research. First, to observe the data of lab testing between alumino thermic and flash bar in EDTP Gemas-JB. Second, to study the slow bend test and hardness test of testing mentioned in ITP for alumino thermic and flash bar in EDTP Gemas-JB. And lastly, to compare and validate the method of welding rail joint in between ATW and FBW in EDTP Gemas-JB. Okay, now we move on to literature review. Literature review. A crucial component of the railway system is the rail joint. Local settlement occurs because of the rail joint are less rigid and strong than the center. The rail joint must have the same qualities as the rails themselves in order to fulfill the purpose and provide constant performance. Alumino thermic technique is used to join lengthy string of flash bar welding rail in the field, as well as to repair worn and broken rail, which is for maintenance. The welding is used on railroad to join rails together. Flash bar welding is characterized by a high stable quality of welded joint that are nearly equal in strength to the parent metal. This is the summary of the literature review. I have compared from type of welding, performance, how it performed, quality, mobility, percent of failure from literature review, and lastly, disadvantage. Based on study and research, both methods have same purpose, which is to join the rail to build a long track with most efficient, but with different method. FBW had a lot of advantage in rail joint of welding because it may weld large cross section, shape material quickly, without the need for interface preparation, cleaning, and with adequate weld strength. Before, FBW exists or worldwide using, ATW was the #1 option for rail welding joint because the material for this method easy to get and final cost for the welding less expensive compared to FBW. It also no need current of supply when the welding needs to weld on the site. This method doesn't have any problem with any location the welder want to weld. To compare both of methods specifically, the researcher learns about lab testing that both oral joint method will undergo, which are slow bend test and hardness test. Both our tests are included in test qualification for rail welding. Slow bend test is used to determine the quality of the railway, while hardness test is to determine the width of the softened zone and the maximum and minimum hardness in the heat affected zone and any asymmetry in the hardness distribution. Okay, next, now we move on to methodology. Next is methodology. Methodology will describe and discuss the planning and method of the researcher to gather the necessary data and information that will be used in the entire of study. Here are my flow for my research. The data from this project was provided from SIPOTL from EDTP Gemas-JB, and the scope for this research was on 2021 and specifically for northern area, only which cover from Gemas to Palu. The testing that involved in this research are slow bend test and hardness weakness test only. Both of the tests had a similarity, which were run in lab and the data much clearer to analyze. Okay, the data of slow bend test that will be analyzed in this research are mean rate of loading, deflection at termination test, maximum load, and lastly, maximum stress in the foot. As for hardness test, the data that will be analyzed is maximum fusion zone. The fusion zone is defined as the portion of the material that has melt. And next, width of heat softened zone. Okay, now we move on to data analysis and discussion. The data was extracted from RFI, which is request for inspection from this EDTP project. This research will only focus on permanent track since Northern area didn't do any ATW testing that related with PS80A in 2021. The first, low band test. This is the constant for solvent test according to Australian standards since we're joint welding for this project use that standard. Based on the analysis here, clearly see that the maximum load that FBW depot and in situ FBW had the highest maximum stress in the foot compared to ATW. The deflection at termination test was depend on the maximum load that welding of joint can afford. The higher maximum of load will produce higher maximum stress in the foot. Based on the standard, also we can compare that the requirement for minimum stress ATW is 750 MPa, while FBW is 900 MPa. It shows that FBW method much more quality and long lasting compared to ATW. Okay, next we go to hardness test. In this project, there are several types of hardness that are involved in this EDTP project for pass the qualification of FBW and ATW on site. The specification and qualification for this test are followed by Australian standard. Since the data analysis will only be focused for 2021 and not the area only, so the data analysis for hardness test will concentrate in weakest test. So here is the constant for hardness test. On the table, all the sample pass the specification of AS standard. It can be proved it refers to the maximum fusion zone and width of heat softened zone. According to AS standard, the specification of maximum fusion zone for FBW and ATW have slightly different, which are FBW is 380 hardness Vickers, while ATW is 430 hardness Vickers. From the specification, it shows that the less value of maximum fusion zone, the higher of quality of joint. However, from the table, it shows that the maximum fusion zone for ATW is much low than FBW. It may due to the technique and competence that have been applied by the welder in this welding joint until it can increase the quality of the joint ATW. According to AS standard, the specification of maximum fusion zone for FBW and ATW have slightly different, which are FBW is 380 hardness Vickers, while ATW is 430 hardness Vickers. From the specification, it shows that the less value of maximum fusion zone, the higher the quality of joint. From the table, it shows that the maximum fusion zone for ATW is much lower than FBW. It may due to the technique and competence that have been applied by the welder in the real welding joint until it can increase the quality of the joint ATW. Last but not least, conclusion. Conclusion from this research, as for current technology in Malaysia, both of material joint of welding are really necessary for every railway project in Malaysia. Even though FBW give a very quality result compared to ATW from every testing, but there's still some purpose of a welding joint that can be fulfilled by FBW, such as to do plug rail, distressing, and GRG and turnout. Recommendation from this research, in future, they may be in any railway project, it might be used only one type of welding or other method that have same or more than FBW in terms of quality. In addition, maybe the material or procedure for ATW can be improvised to get much higher the quality from the current project. From this study, people will acknowledge and understand the method of welding, which is ATW and FBW in a better way. In addition, engineers that involved in railway project managed to differentiate between these two types method of welding joint, which are FBW and ATW, from the benefits and the performance. By the end of this research, people that involved will gain more knowledge and able to improve for better implementation for future project. For further research, researchers may continue to research and compare the data of on-site testing, such as non-destructive test, which is ultrasonic test, and visual geometry test. So here are lists of my reference. And here I have attached example of analysis. This is for slow bend test. And this is for hardness test report. So that's all from me. Thank you.